Further to my video on resolution of vectors in two dimension, we will see some extended useful results. So this result says if vector A and B are two non-collinear vectors in a plane. So we have vector A and vector B, and they are non-collinear vectors in a plane. Then any vector in the plane can be written as the linear combination of vector A and B in a unique way. So any vector, which is we're going to use and show that vector R, can be written in a unique way in terms of vector A and vector B. That is, any vector in the plane is of the form LA vector plus MB vector for some scalars L and M. So which means vector R can be represented as LA vector plus MB vector, where L and M are scalars. Let's see the proof. Let OA be equal to A. So we have defined that OA as vector A and OB as vector B, and R be any vector coplanar with A and B. R is coplanar with A and B. Next, draw PL parallel to OP. So you need to draw PL parallel to OP. So let's do that. So that's our PL, and it's parallel to OB. Now we can clearly see that our LP is, since it's parallel to vector B, it can be written as MB vector, and our vector OL, since it's parallel to A vector, it can be written as LA vector. Okay, where L and M are some scalar quantity. Now OP vector, which is this R, OP vector, is equal to OL vector plus MP vector. Okay, so it can be replaced with LA vector and MB vector, and we can say vector R is equal to LA vector plus MB vector. So therefore, if R vector, A vector and B vector are coplanar, then R vector is a linear combination of vector A and vector B. In the next result, if vector A, vector B and vector C are three non-coplanar vectors in a space, then any vector in the space can be written as LA vector plus MB vector plus NC vector in a unique way for some scalars L, M and N. So just to illustrate, let's call this as vector A, vector B and vector C. Then any vector A, B can be written as, let's call this as any vector AB, can be written as LA vector plus MB vector plus NC vector, where L, M and N are all scalar quantities. And here we'll define the rectangular component of a vector. Let I cap and j cap be the unit vectors in the positive directions of x and y axis. So we have in the x axis I cap, and we have in the y axis j cap. Let R be any vector in the plane. So R is defined as our vector in the plane. So this is our x-axis and this is our y-axis. Then the vector R is equal to x I cap plus y j cap. So for some real number x and y. Now if the position or the point, the coordinate of P, OP, which is represented by R vector, is x and y, then you can express this. So this point is x here and this point is y here. Yeah. Now you can express this length as x I vector. And you can express this length as y j cap vector. Okay, so then here x I cap and y j cap are called the rectangular components of our vector along the x and y axis respectively in 2 dimensions. So our x I cap and y j cap are called the rectangular components. Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.